So that's the introduction. Now we are going to have a quick look at the marine propulsion system, marine propulsion using batteries. What is the situation of using batteries for marine propulsion? Right. So if we try to look at the batteries powered by ships powered by batteries. So on the left side, we can see. So in terms of ship types, what are the ship types being powered by batteries? The most obvious one is the passenger vessels and the ferries. These vessels actually they have quite short distance to sail, and they have more fixed routes between ports. So which means they would have much easier access to the charging infrastructure. That's one of the core reasons behind why we are seeing a lot of battery powered ships, actually passenger and ferries. And on the other side, offshore vessels. Offshore vessels, they have really complex operating profile. For example, ships with dynamic positioning. So for offshore vessels, we can say mostly they are in hybridization, mostly diesel engines plus the batteries. So basically, batteries can optimize the loading for the engines and also try to improve the redundancy and reduce the maintenance requirements for the engines. A few other types are cargo and tankers, and also the other ship types. So that's the overview about the ship types. So what we can see from this chart. So basically, these vessels can be either only fully battery powered, could be ferries or car carriers sailing on really short distance, for example, between two cities for 1 hour or half an hour. Okay, and because they have really good access to the charging infrastructure. On the side, the hybrids could be for offshore vessels, for ships with really complex operating profile. Okay, so basically, it could be offshore vessels, could be other coastal shipping vessels. If we try to focus on the right side, what is the trend in terms of number of ships? So these number are a little bit outdated, but in general, we can see an exponential trend in terms of number of ships powered by powered by batteries. Right. So what are the battery ship typical examples? So on the top left side, because basically we can see the Viking Lady vessel, which has a 450 kilowatt lithium battery in hybridization with diesel engines and fuel cells. And on the top right side, we can see this is another ferry, but it has much larger battery capacity in hybridization with the diesel engine. And on the lower left side, there's a full battery powered lithium battery. And one thing to note is we do have charging constraints on this particular vessel. So by the end, basically, they have to swap the battery packs with the vessel with another pack being charged on shore because the impact to the grid power. On the right side, that's another example of the vessel with battery claimed to have more than 6 megawatt hour capacity in hybridization with internal combustion engines. So basically, we can see two types of battery typical use. The first one is full battery power for ferries or really short distance vessels. The other one could be hybrids, for example, the offshore vessel, Viking Lady, another vessel in this case. So basically, the batteries would be able to optimize the loading for the other power source, for example, the engine, but it's not necessarily only for engine. Later, we are going to focus a bit more on the fuel cells. Right. So if we try to look at the status of the marine battery, and we compare the energy density with the conventional lead acid and nickel batteries, basically we can see lithium batteries, it can actually offer much better energy density, and so it's quite a few times higher compared to the conventional battery technologies. But on the other side, one thing to note is, so let's say when we look at the energy density, so typically the battery cell manufacturers, they will provide the energy density in terms for the cells. But one thing to note is when we integrate the battery cells on board the vessels, and we'll have to consider the packaging and all the auxiliary systems, for example, cooling and cabling, all the things which are auxiliary things, and basically these will further reduce the energy density of the batteries. And we'll have different battery chemistries. Some battery chemistries are better in terms of delivering high power, and some battery chemistries are better in terms of energy density. But the main message is we cannot get everything from the same battery and chemistry. Basically, there will be a sacrifice or trade-offs between different options. So that's in Figure 8, basically we have a comparison for different battery chemistries from different perspectives, and then the energy density, both volumetric and grammetric for different battery chemistries. So that's the point I previously mentioned. Let's say we have the battery cell, but when you put the battery cells into a fully functioning module, basically that's how it looks like. So we have thousands of cells connecting in parallel series. But on the other side, you have to arrange the battery packs, which includes a cooling system, battery management system, all the protection functions, and by the end, that's a complete cabinet you can have on board the vessels. On the other side, one thing to highlight is we all know the battery capacity, they have a state of charge. For example, for our phone, let's say we have a state of charge from 0 to 100%, and normally we don't want to fully use the full state of charge from 0 to 100%. Normally we use from 20% to 80% or 90%. So the reason behind that is actually if we discharge beyond 20% or we charge quite often above 90 or 80%, basically we are going to degrade the battery at much faster rate. So basically we'll have to consider these kind of limitations. The main message behind this, basically by the end, these 20% and 10% will further reduce the usable battery capacity on board vessels. So that's another challenge, basically. By the end, we'll have to consider if we have all these constraints on board vessels, and then for some vessels, actually we will find that the battery only solution is not feasible, and then you need another power source to achieve the required range for the vessel. But one thing to note is, so we are at the stage currently around we are having the cell level energy density like 200 or 300 watt-hour per kilogram, but that's not the state we will get for the next 10 or 20 years. So basically, we are seeing a lot of different battery chemistries being developed and being commercialized. And I hear a few advanced battery technologies which might be available in the next few years. So there's huge potential here. But in the meantime, we have to use hybrids to compensate the energy density limitation for many reasons. Okay. And we did a quick case study for a typical coastal bulk carrier. So basically, these are arrangement, and it's a coastal bulk carrier with a sailing distance for 100 nautical miles. And in the original powertrain, it has a 4-stroke medium-speed diesel engine, and this is the original setting. So we did a case study to say, if we try to retrofit this power and propulsion system with a battery system, what might be the system weight and volume for the propulsion system and the cost. And by then we found out if we use the battery to replace the diesel system, and basically we are seeing the battery system capacity, volume and weight will be a few times higher, and also the cost compared to the original diesel-based system. So basically we have huge challenge in terms of energy density, both colorimetric and volumetric for the batteries. So if we can vary the speed, because we all know the ship's power and speed curve. If we vary the speed of the vessel, and basically we are going to decrease, if we reduce the design speed of the vessel, basically we can see the required battery capacity will be reduced, so which will be reflected by the total mass of the battery system. But that's something you have to come up with another solution. If we are going to reduce the vessel speed, and then other vessels going to be able to meet requirements into the sailing speed required by the client. So that's another view about the energy density if we vary the speed of the vessel, and then basically in terms of impact to the volume. Okay. But on the other side, cost is more interesting. The reason behind is, let's say if we have, for example, for the phones, let's say for the mobile phones we are using, and then the battery, we would have to replace the battery every few years. So this will be true for cars, and will also be true for ships. So basically, every time we replace the batteries, basically there will be an increase in terms of cost. But from a long-term perspective, we are expecting to see that the battery cost will be decreasing over time, and then life expectancy we can expect from the batteries will be increasing over time. So basically, by the end, if we compare the overall cost coming from the batteries of course, under this particular setting, and then the total throughout life cost coming from the battery system and the original diesel system may not be that obvious, okay? But depends. It's quite difficult to predict the energy market, right? And but something is quite certain for in terms of CO2 emissions. Of course, there's no emission being emitted from the vessel or from the ship, but when we charge the battery, we have to rely on the electricity. So basically, that's a life cycle analysis. So electricity is being decarbonized in a lot of countries, in the UK and in a lot of European countries, and also I believe that's also true for China and Turkey. So basically, we are seeing decreasing carbon intensity coming from the grid electricity, basically over time. So basically, we are going to see the accumulated CO2 emissions coming from the vessel will be in a reduced trend when the vessel approaches the 30 years life mark. But if we use the diesel system, basically that will be increasing linearly over time. Right. So a really quick summary about the battery ships technology. First point is the battery ships, the battery technology still needs a lot of improvement in terms of energy density and also safety. We do have a lot of concerns for the battery safety. And on the other side, when we design the battery ships, so we will expect a lot of impacts to the ship design, which will be quite different compared to the conventional power and propulsion system designed for conventional ships, because battery will be modularized and then they would have different requirements in terms of the auxiliary systems. But on the other side, they have to be reinforced in terms of the structural side. Okay, and we look at the existing and what might be the future battery ships and in terms of capacity. And I think by the end, emission will be one of the key drivers, which is similar to the decarbonization for road transport and also for aviation. Regardless, whatever technology we are choosing, by the end, emission will be one of the key drivers. But on the other side, the vessel or the powertrain has to be commercially competitive. Otherwise, nobody will be using that.